In this video, we're going to look at how pressure and volume stresses on a gaseous equilibrium system are represented on a graph, both at the moment of the stress and as the shift afterwards. Here we're going to look at how pressure and volume stresses look on a graph and how shifts after these stresses appear. So we're going to study the Haber process. So we have nitrogen and hydrogen in equilibrium with ammonia. In this equilibrium system, we have 4 moles of gas on the reactant side of our reaction, and we have 2 moles of gas on the product side. So whenever we're dealing pressure and volume stresses, we always need to know the number of moles of gas on each side of the reaction. So we have our graph. Nitrogen is in pink. We see equilibrium has been established. Hydrogen is in blue. We see equilibrium established and a change 3 times as big as that for nitrogen. And then ammonia is in purple, and again we see an establishment of equilibrium and a change twice as big as that of nitrogen. So we're going to introduce a stress at the indicated space on the graph. This stress is going to be a decrease in pressure, so an increase in volume. So every time we decrease the pressure on a system, we increase the volume of that system. It's easiest to think about these stresses in terms of volume. And the reason for that is that if we think about concentration is moles over volume. The number of moles is going to stay constant. If we greatly increase the volume, the concentration will go down. And because all of our compounds are in the same vessel, the concentration will go down for all of our compounds, reactants and products. So we'll see a sudden drop in the concentration of all species in the reaction. So that sudden drop tells us that we've increased the volume by decreasing the pressure. We have a bigger volume now. Anytime we have more space for gas, the reaction will shift to the side of the equilibrium with more moles of gas. In this case, it will shift towards our reactants. And so the concentration of our reactants will now increase, and the concentration of our products will decrease. Once equilibrium has been reestablished, we can introduce a new stress. So this time our stress will be the opposite. We are going to increase the pressure by decreasing the volume. And on a graph, that's going to look like a jump in concentration. The reason being, the same as before, we have concentration equals moles per liter. If the volume decreases, then the concentration will go up. So we're going to have a sharp increase in our concentration of all of the species in our equilibrium, followed by a shift. In this case, we have less space for the gas, so our equilibrium will shift towards the side of the reaction with fewer moles of gas. So more ammonia will be made, and hydrogen and nitrogen will be consumed. So our first shift is a shift left towards our reactants. We see an increase in the concentration of reactants, and we see a decrease in the concentration of products. The reason that we have the shift left is if we decrease the pressure and increase the volume, our reaction will shift to produce more moles of gas. Our second shift is a shift right. And we know that because we see a decrease in the concentration of our reactants and an increase in the concentration of our products. If we decrease the volume, the reaction will shift to produce fewer molecules of gas.